Bolt.new helps you build full stack apps in the browser. Today's video, I'm going to dive into the code behind it and show you how they make this magic happen. Here you can see it's already running. I've asked it to build me a Remotion app, so it's doing an npm install, npm start. This is all running in the browser. So you can also run Node.js code and front-end code. And look what we have over here. This has already gone and built it with JavaScript code. That's amazing. A lot of videos will show you what you can do with Bolt, and I am going to do that today, but really the core of this video is diving into the code behind the project. The code for this project is open source, it's available on GitHub, so I'm going to dive in and show you how it really works behind the scenes. We're going to learn about the technology that makes this happen called WebContainer. We're going to learn about xterm to run a terminal in the browser, and we're also going to dive into the AI prompts behind it. Last week, I dived into the code behind a similar project called Sourcebook. It's an open source self-hosted AI powered app builder. Now, Sourcebook is very cool, and how it works is it will actually save the files to disk on your own computer and run them like via Node. So you have to have Node installed on your computer for it to work. Bolt is really cool in that it actually runs fully in the browser. It doesn't care what's on my computer. It's not installing anything. And the video before I actually did on trigger.dev, which is also worth a look. And that's interesting because it's an open source background job platform, and there as well they have to run code on your behalf. So here is some task code they would have to run on your behalf on their servers. So across these three videos, you're seeing three different approaches from different teams as to how to run code for users on their behalf. All three projects are open source, so take a look at the links in the description below and subscribe if you want to see more open source projects like this and how they're built. Lastly, I'm working on Inbox Zero, which is an open source email app. It helps you manage your email more efficiently with AI. It's got over 9,000 people using it, and it's fully open source as well. Love your support by giving it a star on GitHub. I'm going to show you a bit more using Bolt. So you can see I've done another prompt to a car video, and it's gone and added this car to the video. And I've also asked it to go and add a plane as well. So you can see all the steps it's taken over here. It's added a plane, a road, a car, and it's really cool. It just did this all on its own immediately. If I want to dive into the code behind it, here you'll see this is the plane. This is just React code it's using, and the library here is Remotion, all running in the browser. It's amazing. And again, we're using the Remotion for the car and for the road, and that's what it came up with. You'll also notice over here, I have a terminal running at the bottom of my screen. So it's done npm install, npm start, all running in the browser. This uses xterm that we'll see shortly. This editor over here is using CodeMirror, and I can even get it to deploy. I could type deploy here, or I could deploy here to Netlify. So let's dive into the code behind it. It's all available on GitHub at stackblitzbolt.new. And over here, I've cloned it to my own computer. The app itself, it uses Vite. We're also using Uno for the CSS. This is what an Uno config looks like. I actually haven't used it myself, but it's a similar idea to Tailwind. And at least back in 2021, you can see in this article how quick Uno really is. Tailwind CSS version 3 took 1 second to do a task where it took Uno only 13 milliseconds, which is insane. I personally don't plan on moving away from Tailwind. It works really well with so many things in the ecosystem, but I think you can get Uno to work with Tailwind very well, and then like libraries like ShadCN as well. So I haven't tried that, but at the end of the day, if it supports the same CSS classes, it should be fairly compatible with other libraries out there. So jumping into the app, we're actually using Remix for this. The app isn't actually super big. You'll see there aren't that many API endpoints. If you're familiar with Next.js, or in Remix, it works a little different. This would be at API/chat, as we'll see later. Some important pieces, we have these stores. So we have nano stores. Nano stores is a tiny state manager for React, React Native, Preact, and so on. And vanilla JavaScript. It's small, it's fast, tree shakeable, good TypeScript support, and it looks something like this if you're familiar with Joteye or Zoostand or other libraries. So you'll see some similar ideas here, but this is used throughout the app, use store and these atoms. You can see a chat store is being created or a file store over here, and it can be used with use store. So let's dive straight into things. I can see over here, I want to know what happens when I start typing some text here and I hit enter. This is going to send the message to the server or do some action. So let's take a look at where this comes up in the app. If I search for it in the app, I'll see how can Bolt help you today. It comes up over here, which is great. And I can see when I do on key down on enter, that's basically what I want, that I'm doing a send message. So let's see how that works. Go to base chat, and that's used over here, which eventually brings us to this part. Here you can see the workbench store. This is one of those stores that I mentioned, again using NanoStore. So the entire state for the app is stored in lots of little NanoStore atoms. And then the important part is where we actually call append. This is the action. And what's that calling? That's from use chat, and this is from the Vercel AI library. You can see up here AI React. So what this goes and does is it's going to go and send a call to our server over here, API/chat. Here's a bit of documentation about the AI SDK, by the way. So you can see we're just importing AI React, just like we've done ourselves. We're doing use chat. And then over here, you can see the messages that come back. So we're just looping through them and showing them on screen. And when we do submit, we're calling handle input change. So in our case, we did append to add messages, but over here, we're just using handle input change, and that basically sends it back to the server, and the server will call the AIs it needs, and then it will stream back responses, and it will just appear here in messages. This is what the backend might look like for it. You can see we're calling OpenAI, a post request, and we're just streaming text back. So very simple to use, and that's exactly what's happening over here. So let's take a look at this endpoint API chat. This is using an action. This is how things work in Remix, but that's basically the equivalent of doing a post in Next.js. You can see the action. So we get the messages in. These are the messages that the user has already sent. At the beginning, it's just going to be one message. And we have some streaming options, but the important part is that we're going to start streaming some text using AI. And then over here, you can see we have the response, which is stream.readable. So it's going to stream the results back for us. So let's go into stream text, and you can see this is basically just calling stream text, which is being renamed as stream text from the AI library again, which is exactly what we saw over here in this simple example. And so we're getting the model, the system prompt. This is important. This is basically where all the logic is happening right now. And we're passing in the messages. You can actually just do it like this. I made a PR to update that today as well. But this is part of the old AI SDK code. You don't actually need to do this anymore to convert message formats. The Anthropic model, we're just calling it from AI SDK. Another PR I made was to update this to the latest version of Sonnet. We'll see if they accept my PRs. And then get system prompt is really what is important. So this is the prompt that we're sending to the AI. Well, this is a system prompt. We're also sending the user messages, of course. And you can see it's a few hundred lines here. I do want to go through this a little bit if you're building your own LLM apps. So this could definitely give you some good ideas. So you are Bolt, an expert AI assistant and exceptional senior software developer with vast knowledge across multiple programming languages, frameworks, and best practices. So here you can start to see we've got these XML blocks, which is the recommended way to do things with Anthropic. It's basically splitting up the prompt into like lots of different sections, and the LLM can understand that very well. So here are some system constraints. Remember, this is all part of the overall system prompt, but within the system prompt, we also have system constraints. You are operating in an environment called WebContainer, an in-browser Node.js runtime that emulates a Linux system to some degree. And by the way, this prompt is really good because it actually explains to us how the project works itself. We're explaining it to the AI, but it also helps us understand what's actually going on. It's sort of like a README for us. So, however, it runs in the browser and doesn't run a full-fledged Linux system and doesn't rely on a cloud VM to execute code. All code is executed in the browser. That's super cool. And I'm going to show you WebContainer as well in a minute or two. It does come with a shell that emulates the ish. The shell there is called JSH, Jish, I guess. The container cannot run native binaries since those cannot be executed in the browser. That means it can only execute code that is native to a browser, including JavaScript, WebAssembly, and so on. The shell comes with Python and Python 3 binaries, but they are limited to the Python standard library only. Additionally, there is no G++ or any C or C++ compiler available. WebContainer has the ability to run a web server, but requires to use an NPM package. So for example, Vite or Server or Serve HTTP server, or use the Node.js APIs to implement a web server. Now we say prefer using Vite instead of implementing something yourself. Git is not available. Prefer writing Node.js scripts instead of shell scripts, as the environment doesn't fully support shell scripts. So use Node.js for scripting tasks whenever possible. When choosing databases or NPM packages, prefer options that don't rely on native binaries. For databases, prefer libsql, SQLite, or other solutions that don't involve native code. WebContainer cannot execute arbitrary native binaries. But that is super cool because you can run a SQLite database in your browser. You can use Drizzle for that. I'll actually show you an example. Here is an example of running Drizzle in the browser. So you can see we've run the migration script over here. Inserted John Doe. This is part of StackBlitz, but StackBlitz is the team that created Bolt.new. So, like, I'm sure a lot of the underlying code is basically the exact same, definitely using WebContainer here as well. Here you can see the table we've created and we're running this migration and so on. And here you can see we've run the migration script over here. Inserted John Doe. This is part of StackBlitz, but StackBlitz is the team that created Bolt.new. So, like, I'm sure a lot of the underlying code is basically the exact same, definitely using WebContainer here as well. You can see the table we've created and we're running this migration and so on. And here you can see we've logged the results after doing query users.many. So that's extremely powerful that runs in the browser. And that's what our AI is dealing with basically. These are the available shell commands, cat, cp, echo, hostname, and so on. So that's all about the system constraints we're working in. Now, code formatting info. Use two spaces for code indentation. I hope the AI isn't offended by this, doesn't start to argue and says it prefers tabs instead of spaces, but you can make the output pretty by using only the following available HTML elements. So here are some HTML elements it can use, A and H2 and so on. So that means when it's streaming the text response to us, the message it can create, it can use those tags, like if it wants to show us a header, for example. Now, diff spec, this is telling us how the diffs work. So for user made file modifications, a modifications tag name section will appear at the start of the user message. It will contain either diff or file elements for each modified file. So if we get this tag, basically a diff tag like this, it will contain a new unified diff format changes. And if we have a file, then it will contain the full new content of the file. So what that means is if I just jump into our, let's say, hello world example and go here for hello world, if I start to type over here, so now when I send the message back to the server, it's going to give this back as a diff. But if I go and do a whole new file, so it's going to pass the whole file to the server and it's going to be within these file tags. The system chooses file tags if the diff exceeds the new content size, otherwise diff. And basically this is what a diff section would be, and this is what a file section would be. So this is like a get diff. So here you can see we've removed this line console.log hello world, and instead we've replaced it with hello bolt. Here you can see we've added this line and we've also added this to the end of it. And how this works is basically you've got at like sort of the start and the end, and then we have like -x. So x is the original file starting line, a modified file starting line. So in this example, it's 2 and 2. We're just replacing code in the same place basically. The original file line count. So over here we basically have 7 lines, and the new file count is 10 lines. So if you see we had 7 lines and we removed 2 lines over here and over here, so now we have 5 lines. And then we've gone and added 1, 2, 3, 4, 5. So yeah, we've got 7 minus 2 plus 5, we get to 10 lines. So that's that example over here. And we're just explaining to the LLM how it works. So that's a diff spec. Now we have artifact info. Bolt creates a single comprehensive artifact for each project. The artifact contains all necessary steps on components, including shell commands to run, including dependencies to install using a package manager, npm, files to create and their contents, folders to create if necessary. So I'm just going to scroll down to the bottom and show you what that actually looks like. So here's the example, user query. Can you help me create a JavaScript function to calculate the factorial of a number? End user query. Assistant response. Certainly I can help you create a JavaScript function to calculate the factorial of a number. So this is just plain text it's responding with, and then it starts to respond with a Bolt artifact. And so that is contained in here, and the Bolt artifact contains lots of Bolt actions. So here you can see we're creating a file, and this is the code of the file, factorial function. And then over here, we have an action, which is running a shell command, which is node index.js. So we create the index.js file, and then we run it with node index.js. And what's cool is that we can intertwine both normal text and also these tags. So later on the front end, we'll be able to parse out the artifacts and the actions from the other text. And that basically goes into something like this. So I'm porting your Stack Blitz project into Bolt over here. This is just regular text at the beginning. And then this is the artifact. And these are different actions within the artifact. And we can mark if it's been done or not and so on. And then here's some ending text. Here's another example. Let's build a snake game. Certainly, I'd be happy to help. So we have a Bolt artifact, which is a snake game. Here you can see we're adding a package JSON file. Now we're doing npm install, and this is a shell command. Now another Bolt action, let's create an index.html, and then finally another shell command, which is npm run dev. And here you can see we did npm install of Vite. And finally some text. Now you can play the snake game. One more example, make a bouncing ball. It's the same thing. Go and write a package JSON, add lots of different files, and then npm run dev. Now that's basically the core of what this prompt does. I will cover a little bit more on artifact instructions, but these different commands and actions are what the AI has to do on our behalf, basically. So it says, look comprehensively at the whole project, wrap the tags, Bolt artifact, Bolt action, current working directory, we're passing that in from the top over here from my function. And by default, that's just going to be home project. Now regarding the shell, always you run the yes command, so it'll just automatically go on to the next step. Always install necessary dependencies first. Ensure code is clean, readable, and maintainable. Never use the word artifact, that might be confusing to users. I like here where we've got important, important, and ultra important. Do not be verbose. Do not explain anything unless the user is asking for more information. That is very important. So I'm guessing they were playing around with this and they really had to convince the AI not to talk too much. And so this is how they got that to work with these ultra important tags. And then the other one, think first and reply with the artifact that contains all necessary steps to set up the project. Files, shell commands to run. It is super important to respond with this first. And then we go on to see all the examples. Now, I spent quite a lot of time going over the prompt, and I typically wouldn't do this, but the reason I did this here is because this is literally the only prompt in the project, which is crazy. So like every time you're messaging, all the messages come into this prompt, the AI responds, we might send it user modifications, it's just responding with all the actions, and we're just going back and forth on that conversation with this single prompt. And that's capable of building full stack apps, which we saw in the browser, which is incredible. So after all of that, you can see we're at stream text. This is where we left off. And so now jumping back to chat action, you can see we get the result, we stream it back to the client. That's being used over here, and that basically sets messages. Now messages, we're going to go and pass them, and that's done with use message parser. But let's see where messages are used. So over here, you'll see parse messages. So it's a use effect. So whenever messages changes, we're going to go and parse messages, which is from use message parser. So let's dive in. And parse messages is going to go and do .parse, which runs this from streaming message parser. Now remember as well, we're getting in the text in chunks. So it's sort of like ChatGPT where it just streams the response. So we could have like half an artifact being sent back to us because full response hasn't happened yet. And so we need to be able to handle that case properly. And I'm not going to spend too long on the parsing logic, but that's basically what's happening in here. And we'll actually be able to jump to the test file to get a better idea. But here you can see we're like looking for these opening and closing tags. And here you can see we're extracting an attribute or title or ID. We're marking when an artifact has been opened. So when there's an open tag or a close tag, we've got callbacks for all of that. And this is a test file for how that actually works. So very basic level. If we're just parsing regular text, hello world, it's just going to give us back hello world. And it should allow normal HTML tags as we saw before. So hello world, again, it just gives us back hello world. Now some examples when we don't have any artifacts. So foo bar with a P and so on. So there are no artifacts here. And here we have incomplete artifacts. So we're still being streamed the result. And so here you'll see foobar bolt A just gives us that same thing back. But over here, when we've got foobar bolt A, and you can see this is a start of an artifact. So it's actually been removed, and this is now the expected output. And you can see examples when we have real artifacts, what it should do. So some text before, some more text. And then over here, we have a bolt artifact in between, and that's been removed from this text. But we've done an on artifact open and on artifact close because, yeah, we have one of each, and we don't have any action. So 0, 0. And then if I dive down here, you'll see a more complete example. Again, we've got before and after at the end of the line, and we've got one bolt artifact, so an open and a close. That's what we're expecting. Here you can see a bolt action, so it's an npm install. And here we have another bolt action, which is a file with some content. And then we close the bolt artifact. And so if we jump to streaming message parser, you'll see how these callbacks are used, if it wasn't fully clear just now. So whenever the on artifact open is called, so we're doing workbench dot basically add artifact and adding this data. On close, we're basically marking it as closed. Now when actions are opened, what we'll do is add action, but not if it's a shell type of action because we need the command to be fully complete before we can run a shell command. We can't do like np and run that. It has to be npm install the full command for it to work. But here you can see we do run it when we do on action close. So if it's sort of type shell, now we can add the full action. And then also now that it's closing, we can run the action. So what is workbench store? Here you'll see we're creating this workbench. As I mentioned before, we're using nanostore, atom, and map. You can see we're creating an artifact map over here as part of our workbench store. And whenever we do add artifact, we're basically just adding artifacts to here. As you can see down here, add artifact. So we did this dot get artifact, see if we've already got it, otherwise just return. And if not, then we're doing set key and we're adding the artifact with its message ID. Here we can update an artifact. Here we can add an action and run an action. And this basically calls another class called action runner. And here you can see we're adding the actions. Similar idea to before. If we've already added it, just return. Otherwise, go and create this action, which is in pending state. And down here, we can see run action. So we're updating the action to be executed true. And then the important part is execute action. You can see we're setting current execution promise. So basically, We're waiting for the previous promise to complete, and then we can go and do the next action. So execute action, we update the action, so we're running right now. And then there are two types of action we mentioned. Can be either a shell action or a file action. Let's look at run shell action. So this takes web container, and remember what we saw in the prompt about like our own version of Zesh or bash. So we've got JSH basically, and this is going to go and run this command in the web container because it's a shell command. And then the other type of action is run file action. So we don't need to run anything there, but we take the web container again and we'll do make directory recursive. We've created the folder, and then we will go and do write file and store the file in the web container. Now, what is the web container, you may ask? So let's spend a few minutes understanding that. Basically, all this code over here, that's great. We can show text in the browser, but how do we actually go and run it? Over here, this could be running on a server and then being sent back to us, but no, it's all fully running within the browser. And so how does all of this work? How can I run Node.js in the browser? And that's where web container comes in. So this is the web container's homepage, dev environments in your web app. This is an example of it running in the browser. So we're just importing chalk from the chalk library. And if I want to run it, node index.js, you can see here we've got this magenta line, and then here we've got this green line, process.version. And this all ran right here locally in the browser. I don't need any internet for that to work. Power your web app with the web container API. This is how we set it up. Like in 10 seconds, we built a web container. So that's that line over here. Then we go and mount our project files. That's basically just our JavaScript files and package.json and so on. Then we can also do things like spawn a command like npm install, or you can also do it via JSH. And then we can also run npm run dev in the browser with a command like this, another spawn command. And then this is what the project files look like over here. These are the files we pass in, and you can just go and run that in the browser. So a deeper dive into how to use web container. Here you can see some app that we're building in the browser. You have a code editor on the left, and you have the app working on the right. This is an Express server, and you have the web container being shown in an iframe over here. Now this tutorial, it doesn't use React or Vue or anything. It's just old school HTML. So we're going to get query selector in HTML and just completely set our app to 0. We're going to add a text area and an iframe to our page. That's the inner HTML of our page. Do a bit of styling, and then we get this. We're going to grab references to our iframe and to our text area. And now we're going to go and set up web containers. So we're going to install the web container API library. We're going to wait for the page to be loaded, and then we're going to do webcontainer.boot. And if I search for that in our project, you will find it as well. That's exactly what we're doing. We're importing web container and then doing webcontainer.boot. And this is returning a promise basically when the web container is ready to be run. And then you can see we are passing in web container basically to the action runner, and it gets the web container promise. So then any time we're using it, we're just waiting for the web container to be ready, and then we're going and doing our command. So over here, run shell action, and we're using the spawn command. Cool, so we've booted it up. Now let's go and create some files. So we have an express file, index.js, and we're also creating a package.json file, which uses nodemon to run it. And now we want to get these into web container. So we're just going to put this into a files object. You can see we have all the code, and that's it. Now we're going to import those files, and then we are going to go and load those files. So all we do is .mount files, and we have them. Now, how do you install dependencies in web container as well? You can just use the spawn command as we saw. So spawn npm install. The syntax is basically first you do something like cd, and then you pass the arguments afterwards. And so this ls command would turn into this with 2 items in the second in the array. Here's an example of npm install. So install dependencies that will help us for the package JSON we have. And so now after we've booted up the web container, we can also do install dependencies. And we can also stream output from this command as well, which is going to be important. So here we do output pipe2 and a new stream. And here all we're doing is console logging it, but you'll see the output of what's happening over here in your terminal. It's not yet showing on screen, but we can get it to show on screen if we want. Now let's actually go and run the dev server. So as you might expect, we can just do spawn again, and we can do npm run start. And this is important because once the server is ready, we're going to get this server ready event emitted, and we can get the URL for this container. And so we can set the iframe source to that URL. And I want to show you that's actually what's happening in our app as well. So you'll see over here, base URL, we're getting it from active preview. We're setting the iframe URL. Iframe URL, you'll see it down here. And this iframe, that's the iframe over here. So everything you see in this section, in this app that's running for me, this is the iframe. Now, if I jump back, you'll see active preview. We're going to get it from the previews. This is from the preview store, workbench store.previews. Let's jump into previews. You can see we're just getting the previews from the preview store. Preview store is over here. And it's listening on that same web container on like for the port event basically. And when the port is ready, we're going to go and set the base URL. And that's basically what the iframe URL we just saw is and how it all works. So over here, we've done web container on port. Here we're actually using the server ready event, but it's very similar idea. And we're just setting the iframe source URL. And here you can see it pop up on the right. Now let's actually go and run the dev server start, which is just npm start. And you can see that we have it. So when a request comes into / basically to our homepage, we get welcome to a web containers app and it's working in the browser. Here's our Node.js code and here is the app running. Now you can also go and write files to the web container. So here's fs.writefile to go and make an edit to the index.js file. We're going to listen on changes to the text area to write to that file. And here you can see we add a blue heart and it appears in our iframe as well. And it's using NodeMon, so you can see here the console logs at the bottom, and it's just updating it in real time. Now, what if we want to show a terminal in the browser itself? And we actually have that over here as well. This is a terminal, right? And we can see we're running at localhost 3000. So how is this built? And so this uses something called xterm. And this is xterm.js over here. So if I do ls, a bunch of fake files, that's cool. So this is a terminal running in the browser. And if you want to use it, just do npm install xterm. And you'll see in our project as well, we're using it as our terminal. So the terminal over here as xterm. We're doing a new xterm. Here's the font, here's the color, and so on. We're adding some add-ons to make it fit. But now we've understood how this is showing up. So let's continue our tutorial. We've installed xterm. We're going to add it to the bottom of the page over here. Oh, right now it's just an empty div, so we haven't put anything in it yet. And then terminal element, we're going to create an instance of terminal. And that's happening here. We're going to open the terminal and we're going to use the terminal element and that's going to pop up the terminal. And here we are, the terminal we wanted. We can style the terminal a bit as well. So using it, just import xterm.css. And now we have a fully styled terminal that fits the page. And now we're going to want to do send output to the terminal. So install dependencies and start dev server. We're going to pass in a terminal and then the output we get, we're going to be able to write it to the terminal. And so right now, when we do the install process, we can have this writable stream and inside it, instead of console logging it to the Chrome console, we can instead write to our terminal and just by adding that line. Now, if you run it, you will see the stuff coming up in the terminal. Now, when we change the text area, because we're using NodeMon, you'll see that down here in the terminal, once again, we'll see NodeMon restarting and we'll have the text logged live to us. It's alive because this is console logging within our own app. Now, so far, we don't have any interactivity with our terminal. So what we're going to do now is allow users to run commands like npm run start or npm install themselves. So imagine we remove the old code we had where we'd automatically run those commands for the user. And instead, we're going to spawn a JS8 instance. So this is going to be our shell process. Now, JSH, we mentioned it earlier in the video, and we can actually go and run commands through it. So instead of having to do like spawn npm install, now we do spawn JSH, and then we go and pass in the actions. So here we do JSH and then something like npm install to get it to work. And so we've started the shell process and we're going to output everything that it gives us. We're going to output it to the terminal with terminal.write. And then we'll start the shell at the bottom of our script. So cool, we have something running over here and you can see our home directory. But we still don't have the option to write anything into the terminal and for it actually to get to the shell. So let's make that happen. We're going to get the shell process input and we're going to write to that input. So anytime we write to the terminal, it's going to be sent to the shell. And now when we start typing commands like npm install and npm start, it's going to send it to our Express Node.js server and go and actually run it. And here we can see the final demo of it actually working. And this is quite meta because we're running it in StackBlitz. So this is its own web app, but this whole thing is running in StackBlitz, which is its own like web app running our web app. Anyway, so we've done npm install and you can see the results. Now we're going to do npm run dev, was it? Or npm start. And see we're even getting the errors. And here we started NodeMon. App is live. It's all working as we said. We're restarting NodeMon. Update, getting the logs here in real time. Just imagine this is a full web app. So I can go and make changes over here. You can see NodeMon restarting and our console updating over here. And let's say I want to change the homepage to something else. That's also happening. So this is Express Node.js server. This is our web app showing on screen. And that's basically how it works as well. So I actually think that covers the core of this project and how you could actually have gone and built this yourself fairly quickly. I mean, there's some amazing technology behind it. The StackBlitz team has been working on WebContainer for years now, and so that made this all possible, but it's all open source, and you can use all this stuff in your own projects as well, and you probably could have built Bolt.new yourself as well. So if we wrap that up, over here you'll see the terminal that we have the code editor. This is using CodeMirror as the editor. You can just npm install CodeMirror and you'll have something like this, or make it a lot prettier like this with a file system and so on. Over here you'll see the preview, which is literally just an iframe. Everything in this section is the preview of the app we're running, and here's the code behind it, and here's the terminal. That all gets orchestrated using WebContainer. It can go and run all the files that we have over here. We just add them to WebContainer. And so the full flow, when I enter some text here and I hit enter, it goes and sends something to API chat. Now we're busy calling Anthropic, and it's streaming results back, which you can see happening over here. It's updating code files, which are happening one by one. You can see each Bolt action is basically happening over here. It's updating this big artifact file that we have with lots of different commands, update, create, and so on. Right now we can't see any code running, but it will run in a second. Here we have an action. It's finally going. I'm not even sure what I asked it to do this time, but wow, you have a car running on the road. Oh, and there you have a plane flying. That's awesome. We saw how we pass all these different actions, and then the shell command, and then that went and ran as well. This is all just being displayed in the UI. Code has been updated. Preview is shown. All the files are being streamed into a web component, or they're being a command like this is being streamed into JSH to be run. I hope you enjoyed the video. I really enjoyed diving into the code behind Bolt.new. It continues to blow my mind how strong AIs are today. In this video as well, WebContainer is also extremely powerful. That we're running Node.js in the browser. So that's the end of the video. By the way, here's one more example if you're interested. Here you can see a full mail client that's been built for me, which is really nice. And yeah, it just works great first time. This isn't one of their preset examples. It's just something I asked it to do in like one command. If you enjoyed, I'd love it if you subscribe. The channel's called Learn from Open Source. Every week we go over a different open source project. Enjoy. Till next time.